A tiny testing framework reveals how JUnit works. We'll build a runner that finds at test, at before each, at after each, and at disabled methods, executes them, and reports results, all with pure reflection. For annotations drive the framework. At test marks a test method. At before each and at after each define setup and teardown that run around every test. At disabled skips a test, optionally with a reason. All are method level and retained at runtime. These match JUnit's own annotations, so once you grasp this, JUnit's API feels completely natural. The runner is a single class. Test result is a simple data holder for pass/fail status. Runtests takes a class, prints a banner, and collects methods annotated with at before each, at after each, and at test. It then filters out any at test methods that are also at disabled. This separation mirrors JUnit's test discovery engine. We split the methods, disabled ones are stored separately and will be reported as skipped. The test class is then instantiated using its noArg constructor. If that fails, e.g., the class has no default constructor, we abort the entire run with an error message. This is exactly why JUnit requires a public noArg constructor unless a custom extension is used. For each test, we first invoke every at before each method, setup. Then we invoke the test itself. If the test throws any exception, we catch invocation target exception, unwrap the real cause, and record a failure. The finally block guarantees that all at after each methods run, even if the test failed, exactly how JUnit ensures cleanup. This pattern is the backbone of any test framework. After all tests run, we print disabled tests with their optional reason. Then a summary line shows counts. If any tests failed, we list each failure with the method name and exception message. This report emulates the final section of a JUnit console run. It turns raw pass/fail data into a clear, human-readable result. This tiny utility scans a class for methods bearing a specific annotation. It's the engine of discovery. By iterating getDeclared methods, and checking is annotation present, we collect all at test, at before each, etc. In a real framework this would be more sophisticated, e.g., scanning for meta-annotations, but the principle is identical. MathTest shows a typical test class with setup, teardown, 2 passing tests, 1 failing test, division by 0, and 1 disabled test. Main hands the class to the runner, which discovers and executes everything. The output clearly shows which tests passed, which failed, and which were skipped, proving the framework works end-to-end. You've built the core of a test framework. Understanding how JUnit finds and runs tests replaces magic with mastery. Now you can explore parameterized tests, suites, or extensions. You already know the engine. Compile all classes and run. The output shows at before each and at after each wrapping every test, confirming isolation. 2 tests pass, the division by 0 test fails with the exact exception message, and the disabled test is reported as skipped with its reason. The final summary counts everything, exactly like a real test suite.